Hello guys, welcome back to Form Fully channel. By seeing the thumbnail, you will get an idea that we are going to see the PySpark interview questions. PySpark is one of the top skills interviewers look for in candidate today. So I'll help you ace those interviews with some of the most common and tricky PySpark interview questions. But in this video, I'll explain what is PySpark, what are components of PySpark, why it is useful, etc. So let's start. What is PySpark? PySpark is the Python API for Apache Spark, a powerful distributed data processing framework. It allows Python developers to write a Spark application and leverage its scalability and speed. While Apache Spark is written in Scala, PySpark lets Python developers take advantage of Spark's capabilities without needing to switch to Scala. It helps you to write code which is compatible with Python. It provides a high-level interface for distributed data processing using Spark Core data processing engine. It enables you to work on massive datasets by distributing data across multiple computers in a cluster, which makes it scalable and faster than traditional processing tools. Key features of PySpark. Distributed processing. PySpark processes large datasets by distributing computations across multiple machines. Basically, it distributes data across several computers, that is nodes. Each node processes a part of the data, speeding up the entire workflow, especially when dealing with the large datasets. In-memory computation uses in-memory storage, reducing disk input-output for faster data processing. Traditional big data frameworks write immediate steps to disk, but PySpark performs most of its operations in memory. This reduces time-consuming disk input-output operations and makes it significantly faster. Fault tolerance automatically handles node failure by recomputing lost data. PySpark is resilient. If a node fails during the computation, Spark automatically reruns the failed task on other available nodes, ensuring the computation continues without data loss. Support multiple languages. PySpark integrates with Python, while Apache Spark supports other languages like Scala, Java, and R, allowing teams with different programming backgrounds to work on the same platform. Components of PySpark. PySpark Core. PySpark Core is the backbone of PySpark, providing basic functionalities like task scheduling, memory management, and fault recovery. It also handles input and output operations across different storage formats like HDFS and S3. PySpark SQL. PySpark SQL allows you to work with structured data using SQL queries. This is ideal if you are working with databases or need to perform joins, filters, or aggregations on large datasets in a familiar SQL-like syntax. PySpark Streaming. With PySpark Streaming, you can process real-time data streams, which makes it a great tool for scenarios like monitoring systems, real-time analytics, or live data processing from IoT devices. PySpark MLlib. PySpark MLlib is a machine learning library that offers a range of machine learning algorithms such as classification, regression, clustering, and recommendation systems. You can train, test, and deploy models across large datasets without needing external tools. PySpark GraphX. GraphX lets you work with graph structured data. It's used for applications like social networking analysis, where you might analyze relationships between people or pathfinding in large networks. Now let's understand how PySpark works. PySpark works on cluster computing model where data is split across different nodes and Spark distributes tasks among them. The driver sends tasks to executors, that is worker nodes, which execute task and returns result. So basically PySpark operates on a cluster computing model. When you submit a PySpark job, it distributes the data across different nodes, computers in a cluster. Then the driver node is responsible for managing the task flow, while executors, that is worker nodes, perform the actual computation. After processing, the worker node sends the result back to the driver node. So this setup allows PySpark to scale horizontally by adding more nodes to handle increasing data volumes or complexity. Next is why use PySpark. There are several reasons to use PySpark. Most common are speed. With its in-memory computation, PySpark can be up to 100x faster than Hadoop MapReduce. It especially true for iterative machine learning algorithms and complex analytical tasks. PySpark also supports parallelism, where PySpark distributes data and tasks across multiple nodes in a cluster, which enables parallel processing. This speed up computation and especially when working with large data sets. Scalability handles large data scales data efficiently. As the size of data grows, you can add more machine to your Spark cluster. This horizontal scaling allows PySpark to handle data sets ranging from gigabytes to petabytes. This is basically designed to handle massive data sets. As your data grows, you can scale by adding more machines to the cluster. Flexibility. It supports multiple data formats like CSV, JSON, Parquet, etc., and data sources like HDFS, Amazon S3, local files, etc. It integrates with various tools and libraries, making it versatile for data processing, real-time analytics, and machine learning. PySpark integrates with various data processing tools, allowing you to mix SQL, data frames, and machine learning pipelines in a single application, making it an all-in-one solution for data processing. Fault tolerance automatically recovers from node failures without restarting the entire process. PySpark is highly fault tolerant. It uses RDTs, that is resilient distributed dataset, to track the transformations applied to the data. If a node fails during computation, PySpark can recover by recomputing only the lost data rather than starting over, ensuring minimal downtime. Python API. Python developers can leverage Spark without learning Scala or Java. This lowers the barriers for adapting Spark in Python-based data science projects. Real-time processing. PySpark Streaming enables real-time data processing and analytics. It allows you to process live data streams, making it useful for applications that need real-time analytics like monitoring, fraud detection, or IoT systems. Seamless integrations work well with big data tools like Hadoop, HDFS, and Kafka. This makes it an excellent tool in environment that already use these platforms for storing or streaming data. MLlib integration built in a scalable machine learning algorithm for large dataset. It includes a wide range of algorithms for classification, clustering, regression, and collaborative filtering. This makes PySpark a powerful tool for building scalable machine learning models on large datasets. Community support, extensive documentation, and industry adoption ensures continuous improvement. Many large companies like Netflix, Uber, and Spotify uses PySpark for data processing, which ensures continuous improvements and updates to the framework. So in summary, I want to say PySpark is widely used because it's fast, scalable, fault tolerance, and integrates well with big data tools. It's flexible for use cases ranging from data engineering to machine learning, and with its Python API, it's accessible to developers familiar with Python. Alright, so let's quickly wrap up what we have learned about PySpark. In this video, we have seen what is PySpark, key features of PySpark, components of PySpark, how it works, and why we should use PySpark. So this summary shows how PySpark is a versatile tool for working with large datasets efficiently and effectively. Thank you for watching, and if you found this video helpful, don't forget to like, share, and subscribe for more such contents.